It is my distinct pleasure to introduce Dr. John Reid. As I mentioned, third time is a charm. John, we're so delighted, we're so honored you can join us via Zoom today. Although we wish you had been here in person, our folks would love to have interaction with you here. Nevertheless, we totally understand your circumstances and that prevents you to be here in person. Let me just say a few words about Dr. Reid. John and I really go back a long time. And since we're both ag engineers in Illinois one time, I think when John left, they kind of slipped a little bit, the department, okay? But for a while, they were ranked #1 ag engineering department in the country. And the thing is, John, after you left, they kind of slipped a little bit, okay? But still, they're pretty solid. And John is highly accomplished. 35 years of a very accomplished career in both academia and industry. He started the faculty at the University of Illinois and in the ag engineering department. And after about 15 years, he then moved to John Deere and for next to 17 years, and extremely successful. And in terms of, it's basically transformed some of the things it's done at John Deere. Looking at the modern technology and automation. John's area really is sensing, automation, and digital agriculture. You will hear more of that through his talk. But really, even during his PhD at Virginia Tech, Virginia Tech is a BSMS, Texas A&M, and he's really ahead of the time. If you look at his dissertation, it's really looking at using this automated tractor navigation through computer vision. So that's just some time ago. So he's already ahead of the curve. So John really has done a lot for both the industry and academia. And then since 2022, I should say, John was recruited back to University of Illinois as executive director of the Center for the Digital Agriculture. And again, was a joint appointment. This is another example of convergence, computer science, electrical engineering, and ag and biosystem engineering. So in that capacity, obviously, he's heading the digital agriculture. And I'm not going to read all his CVs. I think you saw the announcement, his abstract and the CV, but suffice to say, he is an amazing individual. We're just so blessed to have him with us today. You know, with all the accolades he has received, probably the one that trumps everything, I say. And in 2019, John was inducted into the National Academy of Engineering. So, and just like Jim is also a member of the NAE, so we have 2 NAEs, and both gentlemen are leading the initiative at the ASAB level. That's American Society of Agricultural Biological Engineers in this CBS space. Last year in Omaha, we had a CBS Day. This year in Anaheim, again, we're going to have a CBS Day. So UTIA, UT is an active participant of that. And so both gentlemen, again, that are founder, and ASAB is forming a CBS Institute, and John is the founding chair of that institute council. So with that, John, I think I have said enough, and we're looking forward to your visionary presentation today with us. So the podium is yours, sir.
Thank you. I can tell you can see my slides okay, I think. And
yes, we can.
Just, thank you for the opportunity to talk to you today. And I've really enjoyed speaking about the transformation of agriculture and this journey towards moving from a current linear bioeconomy to a circular bioeconomy with various groups. And each time it's a different result. So I'm hoping you all have a good result today as a result of what I'm going to share with you. Thanks so much for the kind comments. And it's been, as I said, I've had a very interesting career, starting with my work at Virginia Tech. Sometime I want to talk with Aaron Webb about, we have a colleague in common that was very influential in my life, is Dr. John Cundiff, who has probably taught me a little bit about systems engineering and systems thinking. And frankly, he made sure that on my desk, I have a copy of a book that he's put together on how to have a roadmap for a biorefining industry in the Piedmont of Virginia. So we need more of that kind of thinking. I'm sure Aaron is going to carry that forward. So let's start with the challenge. We have a global bioeconomy that is under stress. With the growing population demand, we need to increase food supply. We have limited and declining natural resources. Our bioeconomy systems that we have today are vulnerable to climate change and variability. And whatever the sources are, we do have high concentrations of greenhouse gases that have to be addressed. Agriculture uses a significant amount of the arable land and fresh water. Food waste is part of this overall system as well. More than 30% of food produced is wasted, and much of it's just discarded in landfills, which is kind of a linear bioeconomy thinking. And we have degradation of soil, water, atmosphere, and other ecosystems. And this is not insignificant from a cost perspective. The U.S. spends 1.1 trillion per year on food, and true costs are estimated to be about 2.3 trillion. So that's a backdrop of we're in a controlled environmental system and need to sustain life in it, and almost as if we are in a closed system, and we're starting to see the impacts of that. I'm going to speak somewhat to a dimension of enabling technologies that make it a good time to be involved in this challenge of circular bioeconomy, and it's around digital technologies. And Hong Wei made some great comments about my experiences in working in this area. It's been I've had a lot of different systems types of opportunities, but probably the longest impact has been on thinking of how digital technologies can be platforms for innovations in food and agricultural system. And I will say that while I'm going to talk about a broader circular bioeconomy today, the reality is all of this work kind of in parts of the system. And so I'm going to dive in deep to the production agriculture system to give you some examples of what's involved and why it's going to be helpful to move towards a circular bioeconomy system. So digital technologies are very much a part of production agriculture today, especially large-scale production agriculture. And they're not uniformly adopted across the ecosystem, but it's resulted in a modern ag operating system that helps us quantify the outcomes of the jobs that are done by farmers, and it's enabled by smart connected machinery. And as a result of that, we've thought about productivity in terms of making an individual productive, but now we're able to look at the precision job outcomes at a worksite level, and even think about how producers can optimize the work site that they're working on, more than just the machinery being optimized. So we're moving to a higher level system in a way, and as kind of a consequence of that, actually, there are key elements in place for sustainable productivity, and I'll be making an argument later about how this is an opportunity to catalyze a circular bioeconomy at least in this particular area. And it may not be complete across all ecosystems, but in this particular one, it's an opportunity. So when we think about agriculture, it is very digital today. And the four primary steps, or there's five, including management, but preparation of the field, planting, seeding, applying, and managing the crop, protecting the crop, and harvesting. All of them are integrated together through machinery. And these machine systems are, quite frankly, mobile sensors that collect data, can apply control algorithms, can make precision decisions, and they're further developing with the advancements in AI to become even more capable. And a lot of this journey, remember, has been on a pathway of mechanization that started more than 100 years ago, that was primarily driven by mechanical engineering innovations and less by digital. And digital wave hit it in the 90s and has been taking place for the last couple of decades. So just to kind of go through this history, and I think the history is important for us to think about, because we often believe about taking innovations and making a step to the next level, and being able to do anything we want and get better outcomes. But actually, this history is pretty important because, frankly, for most of the first 100 years, it was all about mechanization and taking labor out of the workforce in agriculture, making it easier for fewer people to make fewer passes with bigger machines and wider implements. And so it's like it's the age of brawn. And it wasn't until the 1990s that the technology stack that would enable digital transformation started to take place. And enabling in there was the GNSS technology, or GPS receivers like you see down here, that essentially enabled precision localization of machinery that could be used for different uses. And in agriculture from that time forward, it really was the launch point was automatic guidance. There were things about precision ag that tried to take place, but guidance was the thing that provided the return on investment for producers and enable them to deal with some of their pain points of labor availability and the challenges that go with that. And the tech stack then evolved in other ways. Connectivity came into play around 2008 to 2010 in that time frame, and understanding how could you share information between machine systems, how could you take that information and take it back to the farm for management and leading to additional opportunities for worksite productivity. And we're in the midst of a phase of higher levels of automation today, and it's kind of whether you're a fan of robotics or not, I think it's got multiple pathways that include robotics. But actually, it's also possible that we make these systems just more intelligent so that the implements on them can help achieve these outcomes. And so it's a really interesting future from continuing the current model and increasing production, given the kinds of constraints we have and the kinds of benefits that we could get. And I'll tie this back into circular bioeconomy here in a moment. So if you look at this machine system today, and here's just an example of many. I spent a considerable time at John Deere, so I'm starting to not use their pictures, but this is a really great example of how you have digital technology throughout the machine, from the controls of the internal machine systems, including drivetrain and engines, to the operator station, which has information that the operator uses to manage the machine, to multiple displays, and including things like automatic guidance. Being able to communicate machine to machine, and then having implements that are integrated with sensing technologies that enable them to create the outcomes of the job and do it more precisely in a precision manner. And then all of that is tied back in to the cloud, through the cloud, to an operations center where data on what was done and what was planned and what was done are comparable, and being able to measure performance of machine systems across different operations, different users, different fleets. All of this is in place today. And that allows producers to get the best outcome for each path across the field. And this is not going to talk about other forms of optimization that's still to be realized, but it's still a journey. These ingredients are in place, and they're still enabling further optimization of these systems. And again, when we bring this back to a circular bioeconomy, we're pretty much optimizing them towards a linear bioeconomy approach. And we're going to have to think about how to leverage these technologies to make a change in a different direction. So in the modern ag operating system, we have, as I mentioned, high fidelity location due to multiple constellations of GNSS, or GPS is the US constellation. It gives us this highly precise ability to localize and control tasks at centimeter level accuracy, and levels of repeatability that can happen across steps in the production cycle. We have connectivity through telematics that allows to share information between machines, machine-to-machine communication, and also track the performance of the machine and even the operator, and understand what types of things they're doing that are consuming more fuel or using less fuel, and better utilization of their power resources and systems. And then all of this comes into cloud data services that help the producer plan operations and manage their crop, and allow them to share data across their value chains with their trusted agronomists or other people that support their operations. An element that I'm not going to talk about too much today, but it does relate to sustainability a little bit, is the opportunity for electrification. And don't expect to see, a battery electric tractor doing large-scale tillage, but it isn't inconceivable that they wouldn't be used in dairy management, where the power requirements are less. And in fact, I'm a strong believer that every powertrain will have electric drives and storage capabilities versus the conventional just linkage to an internal combustion engine, because we're going to be able to get better optimization and conserve fuel, which is going to be a benefit for sustainability. Digital technologies are really in an interesting phase right now because you're starting to see evidence of this in the market, of how they're helping in other areas, and based on AI capabilities. And so a couple of examples that relate to my career: improving machine performance through guidance, vision-based guidance. Hong Wei mentioned I was doing this in the mid-'80s, and it's very, very highly commercialized today. Path planning of missions across the field can efficiently enable a producer to cover a field in a minimal distance to achieve the maximum outcome. And in augmenting human performance is another example where combines with a tractor grain cart can use sensing to position a tractor relative to the cart, so that there's an unloading on go, and it synchronizes the activities between machines. Synchronization between machines is really interesting because it drives to the efficiency of the machine system. But I can tell you from an industry perspective that it's often hard to have a business case about optimizing across two different parts of the company. And so even in current precision agriculture, we have this systems level thinking that's really important to drive these kinds of outcomes. A big opportunity is, can AI and autonomy help multiply human performance? So autonomous operations, you're starting to see a few examples where companies are thinking about this and demonstrating examples of it. Some of them are deploying at large scale. This is an idea of being able to take this workforce that we've condensed down to fewer and fewer people and give them the resources they need so they can double their productivity by having an operator in a manned machine and an autonomous machine working collaboratively. And even exceeding human performance is interesting, because you're starting to see on the market high precision selective spraying that uses AI to sense the weeds and only spray at the targeted chemical at the targeted weed. And it's beyond human performance because, well, we could do it, but not productively. We would be able to walk through a field with a wand and make decisions with our brains that do that. But can we do it at 15 to 20 miles an hour in a 110-foot wide boom to be able to achieve that? So actually, I think this is an interesting space because, deviating from circularity a bit, is that we often think that the next step is autonomy, but frankly, smart, intelligent implements might be a better step because we can leverage the existing operators to help achieve that. On the journey to autonomy, we need to know how to do these things in any case. So, in this section, I've tried to show how the digital technologies have matured, and there's data from these mobile machine systems that are performing work tasks, but they're also sensing what's happening in the environment. And there are huge opportunities to leverage that data for other purposes in the production system. And we'll start shifting into how this relates to circularity and sustainability. Now, okay, I did want to stop here, though, and say, despite these advancements, it's impressive, but it just feels like something isn't quite right with these solutions. And there's a couple of challenges. And actually, if I would be in there in the audience, I would let you participate and add to these. But some of them are good things that have happened, but some of them are challenges. And first of all, I'll start with this ability to measure data is pretty important. Actually, I'm a fan of Peter Drucker, and if you can't measure it, he would say you can't improve it or make it better. And I think we're in an age where we're starting to see the impact of that, and it's affecting our thinking about agriculture and leading to circularity. It's revealing because we now see this highly mechanized systems, but realize that there's high levels there's opportunities for recovering waste in them. And they're very highly mechanized systems of a linear bioeconomy. And the challenge is that we've been mechanizing them for 100 years. So if we decide we want to do it in a completely different way, that's going to be a huge challenge. So we're going to think about the journey to circularity. Also, we have these productivity gains, but now that we can measure things, we always have known this, but we have a deeper realization that the dependency on fossil fuels is really highly correlated with any gains in productivity that we get. The mechanization made equipment bigger, but bigger machines consume more fuel in doing the operations. We have more synthetic fertilizers from fossil fuels and Haber-Bosch processes. Pesticides and herbicides and irrigation all are inputs that depend on fossil fuels, and transportation and distribution. We get beyond the farm and thinking about the supply chain. All of that requires it consumes fossil fuels to make it happen. And in fact, we have not really thought about the length of supply chains. It's been anywhere and everywhere from the particular farm. Another challenge is that I've already addressed this, is that it's been a linear bioeconomy that has evolved. It isn't at the beginning of its phase, and there's not necessarily some easy jump off points. We're going to have to think about the diversity in the future in favor of productivity. We have a lot of monolithic and very similar production systems used for the commodity crops. And of course, the farmers are seeing some impact of that from disease resistance and those types of problems. And we've also kind of, in a second topic, is we've optimized for removing the seed and grain for food production from the field and haven't paid attention to the excess biomass that is there. And so, for example, if we decide in the future that there are value-added purposes for the corn kernels, as well as the cob and parts of the stalk and the rest of it we want to put on the soil to keep the soil healthy, there's no real easy way to do that with the current machine systems, because they've been designed to optimize removing the grain from the field, and that's it, or the corn kernels. And then the other biggest challenge here is that I've had the good fortune to be working on these types of problems for large companies that sell large equipment systems to high-end producers. The technology benefits in the portfolio have not even scaled into the lower ends of the offerings of these companies. And in some ways, there's a concern about how do we help the small to medium enterprises achieve levels of productivity. And you remember in my earlier comments that the revolution for production agriculture started with automatic guidance. And that's not necessarily going to be true for small to medium enterprises. However, they could possibly benefit from the data. And in fact, maybe this device that they're carrying in their pocket is a tool that's a different pathway for them. And we need to start thinking about alternative ways to achieve these outcomes. So this drives us to thinking about this highly productive linear system and to thinking about a deeper understanding of the bioeconomy. And I think all of you are aware of linear versus circular systems, but just to kind of reiterate this, when we think about the inputs that we've just described, we are thinking about them going from pre-production to production to post-harvest to consumption. And the outcome of all of this is waste and losses. And sometimes those losses result in greenhouse gases and impact, but there's also impact to the soil, biodiversity, the water and nutrient flows into rivers and those types of things. And so it's extremely productive. If we're only measuring productivity, we can continue doing what we're doing and gain productivity. But the cost is basically the value of the bioproducts, materials, and resources are only maintained in the economy for a short period of time. And we're not considering the consequences of these losses and waste. In some of the systems are optimized, but they're not optimized in a way that considers the multiple factors that we're considering here. So the real enlightening thing about circular bioeconomy systems is we start thinking more holistically about things from end to end, starting with the resources and inputs that go into production. And I've been only really focusing on agricultural production systems, thinking about how those then carry their circularity benefits into the next phases of bioprocessing, post-production processes, and leading back to the use and in understanding what we have in terms of resource flows for recovering. So there's this part of a bigger system of systems, a more complex system of systems, that is the challenge and opportunity for circular bioeconomy systems thinking today. And just as another way of looking at this that we've used in our projects here at Illinois is that the pillars that people tend to have optimized around are precision ag, and we're starting to think about regenerative ag. And I draw it as a circle because it's actually, if you looked at it from the side, it would be silos. We do our innovations inside of these silos. And we have a food production and biofuel production silo. And we have the consumer marketplace. And what we have really lacked is an understanding of the connectivity from inputs to outputs between these systems. And how do we get from one to the other? If we're going to have circular bioeconomy systems, we're going to have to think about reducing, recycling, reusing waste productively, and maintaining it as it flows through these systems. And we're going to have to start optimizing at a higher level. And then on the waste side, there are opportunities to recover resources. And this is a new silo that showed up in the system that thinks about wherever waste is occurring, how can we keep it in play for longer and take advantage of it to make more things we need from things that we grow. We'll come back to that. So it's great that we have the digital technology as we go into this thinking, because as I mentioned, if you can measure it, you can make it better. And so one of the dimensions is that it's a platform for sustainability and bioeconomy transformation that we're starting to realize. And actually, I want to go back to the industry side a little bit, because in this value chain of stakeholders, we have input providers and OEMs that make equipment, and all companies today are starting to respond to issues related to sustainability to their investors. And here's kind of an example that shows that if we take our enabling technology that we have here from John Deere, that includes using computer and digital technologies and highly automated machines, they are claiming that by 2026, they are going to reach 500 million acres of engaged operators, which means that they're connected through their operations center. They're monitoring and have digital data to help make these processes better. And 75% of that are going to be sustainably engaged by 2030. And I think if you don't know sustainability reports, not everything that happens in them come true, but companies really work hard to make them true. So there's a belief that there's a connection between the success of the company and helping make impact on sustainability objectives. Now, that connects back to our farmers as a result, because a lot of companies are looking at science-based targets, which, if you're familiar with their terminology, they have some things that companies can do called Scope 1 and Scope 2, make your manufacturing greener and cleaning up waste streams in their factories and their business operations. But the Scope 3 is really interesting to me, and because it's basically thinking about how can the company's products impact the indirect emissions in the value chain of what they're reporting. And that includes upstream and downstream. So they start thinking about the transportation and distribution of their products and how they can make that greener or more sustainable. They start thinking about, are we sourcing raw materials that are done in a proper way, more sustainable way, or do we have green aluminum in our product? But the really interesting thing from the perspective of the farmer is the use of the products. And that's the downstream side of that, where they get benefit if the company can cause the farmers to consume less fuel, be more efficient, to optimize their systems. And And the good news about that is that with the digital technologies that I just shared, they can document how that's working. And so they can measure it and validate that those types of things can be achieved. I don't know if they were able to, any particular company has gotten ahead to do this yet, but the fact of the matter there is that now there's a connection between what the farmer does and what the companies can help them do more sustainably. So now we move into the broader challenges of addressing the bioeconomy systems. It's more than just the production ag side that I've mentioned. And instead of just looking at productivity, we now have to look at multiple targets to pursue. Decarbonizing, regenerating, eliminating waste, reducing environmental degradation, displacing fossil fuel sources with biomass carbon sources or alternative fuels, increasing food security and resilience, and transforming the economic potential. And the CBSI group has been thinking about this for a while at ASABE, but reality is that this is, if you've worked inside of a silo making a system better, if you work inside of your single discipline on what you can do to contribute, circular bioeconomy is going to pull you into more integration of disciplinary perspectives. It's transdisciplinary. Actually, in some ways, as the picture shows, people are getting back closer to the land and understanding the implications. They're starting to realize they lived in a controlled environmental system that just happens to have some pretty nice benefits of water and resources and air and climate that sustains growth through photosynthesis and other benefits. But we have to start thinking about these things more, and then also we have to start looking beyond just the system we work in, but its interconnectivity to other systems. It's a system of systems problem. Actually, I'm going to click through this a little bit, but Jim Jones will be familiar with this because as we transform for this, it's going to be important to have some measures. And this is one that Jan Huizan, Jim, and I have worked on. It's online in a free. You can actually download this paper. It's something that's new for me in reviews is that they don't wait till it's approved. They start publishing it right away. But this is a paper about developing a circularity index that can basically help us look at a system and look at the different inputs or areas of interest and understand their level of circularity of those systems as it's a single number that's based on the how the sources of these elements of the system are connected to renewable resources, or whether they're natural, consumable, renewable, recovered. So I think this is on one side a linear system. You see we have an idea of taking, making, distribute, use, and dispose, and we maximize our productivity in that context. Whereas with a circular system, rather than dispose, we recover, remake, and reuse to the extent that we can. And we're still developing this, but we found that it's a good way to compare two systems. So now with our different types of data we have, we can compare economic systems, we can compare nitrogen balances, we can compare water, we can compare productivity, and we can actually, for each of those, look at it in a way in terms of its circularity. And having a number that can help us drive that is important. This may not end up being the right solution at the end of the day for all problems, but it's a kind of a step in a direction. Is how do we take these digital technologies and leverage them in a way that we can make decisions for circularity. So we do have some challenges in this changing objective function. We want to measure more things, assess circularity, but this is not a standard engineering problem any longer. It involves society, it involves politics, it involves changing. Remember, all of these systems have been built up around linear approaches and linear thinking and benefiting the larger segment of producers and not seeing the nuances between smaller producers and larger producers. And so I'm going to spend this section talking about some of the elements of this type of system. So, for example, in order to have, I mean, agriculture is part of us having food security. And so we want to deal with these challenges of climate change and reduce the carbon footprint. And but we also have to start thinking about supply chains. All of these things fall apart in extremes, but we actually have not considered the supply chain for providing for society. And we have a really great research team here at Illinois who is basically coming up with ways of visualizing the global supply chain and seeing the inflows and outflows. And it would just really surprise you, maybe not, to see that a lot of times, if you look at the countries that have water availability issues, they are often the places that are exporting water in the form of food products to other parts of the world. And so we need to start thinking about this part as well. And it's going to be impossible to perhaps shorten all supply chains in the world, but we can make some decisions about ways of doing this that try to provide regional coverage and reduce the impact of supply chain. So the opportunities are there for taking the innovations in precision ag and biotechnology and helping make some of those changes, creating the circular bioeconomy methodologies give us a way of thinking about sustainable practices in circular bioeconomy. And we need to start thinking about this urban-rural divide and why does it exist? And what could we do about that to bring opportunities for agriculture and the circular bioeconomy back into our urban, suburban, and even parts of the country that aren't flat like Illinois and have become growers of commodity crops. How do we bring other types of cropping systems that contribute to circularity into across the entire landscape of the country, across the whole world? And then we need policies to encourage expanding this type of global collaboration, because as you can see, I mean, actually, we already observed that some nations, Germany and Europe, for example, China, are starting to think about this circularity thing. But at the end of the day, the air, the water, the planet, we're all still inside the same systems. Can you imagine being on a space station and you would have the kind of thinking that we have on the planet about, factions taking care of each other? It wouldn't be a very easy thing to imagine being successful. Well, we have that challenge here is that everybody's interested in circularity, and it's great that we're starting to see it as nations, but we're going to have to start thinking about this more holistically because we are all interconnected. And in terms of agriculture and national security, it's important that circularity there's no easy step of starting here and, we're there. We're going to have to think about that there's going to be jobs created that don't exist today. We're going to have to transition jobs that exist today out and help reskill people into a circular bioeconomy. The circular bioeconomy has to have value to the GDP. We can make arguments that the current linear economy is so valuable. Why would we change it? Well, we have to move beyond that and understand how do we create value platforms for circularity. And we're going to have to think about from the food independence perspective, driving more regional sufficiency, at least regional self-sufficiency, having supply chains that are resilient to events that happen, and think about how we work more internationally and cooperate with others. And then on the political side, our policy and governance, it's really impressive to see the agencies today and how they are really, all of them are really diving after circularity. So this is a really good time to be involved in this, and there's lots of funding opportunities where when I read it, I see the kinds of systems that we think about creating. But we need to start changing some of the policy and governance frameworks because they really were built around linear thinking. And we don't actually have such an easy job here today and in some of the political spheres. It's more integrated. It's not state by state. It's support for sustainable practices. More research is needed for cross-transdisciplinary funding types of opportunities. And there's going to be a need for a different infrastructure that's needed to help circularity where if we're going to displace fossil fuels in particular. And all of this requires collaboration and innovation. We need to start working together across our institutional and regional boundaries to have better multi-stakeholder partnerships, expand research networks, do cross-sector integration, and look at how do we work together to understand this transformation without going through the long process that we've went through historically? Can we work together in a collaborative method and make this happen in a in more rapid manner? So this will be a little bit fun. So you may put me in class of one of the most unusual speakers you've ever had because of this. But you know, kind of the other side of this is there's always well, you know, why do it, or is there an easier alternative? And my good fortune this year in being involved in CBSI is I got invited to a couple of events that struck me as odd at first. One of them was a space agriculture event where we were thinking about you know, traveling to Mars or living in space, and you know, there is a kind of a group. I'll show you a text that I'll recommend you read if you're interested in it. There's some thinking that, you know, we've already messed this thing up here on Earth. Why don't we just go to Mars, and you know, let's just, like, you know, make our life easier. We'll start on a new planet, and actually that's kind of the subject in this book, A City on Mars by Kelly and Zach Weinersmith. And you know, so I guess I just will say is that when I've really looked at this, and you try to do this from a systems perspective, and whether it's in near Earth orbit or on a journey to another part of the galaxy or solar system, or if it's even just to another planet setting up, all of them are harder than what we have to do here. And all of them have less resources than we have here. So, you know, food production in space will demand utilization of these same principles of circularity that we've been talking about. And it'll be hard. You know, it's probably, we're a couple of centuries away, according to the authors, from being ready to really seriously talk about this. And by the way, I've always been disappointed with food, and I'm a science fiction fan. I've always been disappointed in how they've addressed how food is handled. It's always a magic thing where, or, you know, oxygen, gravity, there's a lot of physics that get violated. So I'm arguing that the best way to prepare for this, if you are interested, is to shift some of our investments, which is kind of a, you know, it's very impressive to see what we're doing, but we need to start thinking about how do we start here, and thinking about how to sustain life if we're going to do this, because it's not, so far we haven't found anything better than this system. So working together to make it last is important. So you might imagine that what we've just walked through is actually almost like a Shakespearean drama. The Fields of Change, a drama about circularity. And you know, I don't know if engineers would like going to a Shakespearean play or not. I've been drawn to a few of them. But what we've kind of shown here of the last 100 years is we've had, our Act One was the dawn of mechanization that's helped grow this capability. In the last century, we saw the bounty and the burden. We start having these big, large production systems producing lots of crop, but we're starting to see water shortages. In the late 20th century, we started to see whispers of warning. And so, you know, whether it's Al Gore or others, we're starting to understand and recognize that there's something to this climate change thing, and there's some impact of, you know, of our waste streams making a impact on society. And, you know, I don't know if we're in Act 4 yet, but we're certainly being able to see signs of it, is that the Great Reckoning just gets to the tragedy part of this, where we have to make a turn for the better or worse. And we, you know, have the impacts of droughts, floods, people in distress. And, you know, if it's not now, it's something that would be part of this story into the future that we can prevent and act on. And then there's the arc of renewal that's really tied into the idea of circular bioeconomy, a new age farm, buzzing with renewable energy resources, green technology, and integrated with the community is the vision. So, you know, every play has a prologue, and I'm going to borrow from my colleague Brahm Verma, or an epilogue, sorry, not prologue. Prologue's the beginning. Epilogue is, in this case, it's a future reflection from the past. And this was said by George Washington Carver in the 1930s, that he believed that the great creator has put ores and oil on earth to give us a breathing spell. And as we exhaust them, we must be prepared to fall back on our farms, which are God's true storehouse. We can learn to synthesize materials for everything humans need from things that grow. And I think that kind of summarizes the opportunity in circular bioeconomy and why we should consider it more seriously. So my first stopping point in the presentation is now, but I do have a few slides about CBSI at ABE if we don't have any questions, and I can cover a few of those slides in the last closing minutes.
Time, right?